In this recording, we're going to talk about isomerism, and these four diagrams show the relationship between four lots of C4H10O. So the objective is to know the definition of and identify structural isomers. So the outcomes would be to be able to recall that definition and understand it, and identify chain isomers, typically seen in alkanes, but can be applied to any molecule which has got a carbon chain longer than 3 carbons. Identify positional isomers. Typically, you would encounter them in alkenes, alcohols, haloalkanes, but you can see them in others. And also to be aware of functional group isomers as typified by ketones, aldehydes, alcohols, and ethers. Now, the first thing to get straight is that some alkanes can look to be different molecules by the way that you draw them. Okay, so here we've got butane. Now, because the single bonds, carbon-carbon single bonds in butane, can freely rotate, it means that this structure here is equivalent to this structure here with kind of the stepping stones, or this structure here at the bottom. All three representations are of butane. Now, typically what we see is students like to call this molecule here not butane but 1-methyl propane. Remember that there is no such thing as a 1-methyl group. So when you come to try and draw isomers, the important aspect is that you name your compound based on the longest carbon chain so that you don't end up drawing 7 or 8 different isomers and all they are the same compound. Okay, so let's look at these two alkanes here. We have got butane on the left hand side and 2-methyl propane. They are different compounds because they have a different displayed formula. Okay, and that is seen by the longest carbon chain. On the left hand side it's 4 carbons, here it is 3 carbons. Now, what they do have in common is that they have the same molecular formula, i.e. they are both C4H10. So this leads us to our key definition. Structural isomers are compounds with the same molecular formula, but they have a different structural formula. The examiner also accepts for you to say they have a different displayed formula. Okay, this is a definition that you do need to know. Okay, so the first type of isomerism then is chain isomers. This is because the carbon chain, the length of the carbon chain changes and the branching occurs. So here on the left hand side we've got butane. It's a longer carbon chain. There are no branches, no groups coming off the side. Here we've got a short carbon chain and we have got one branch coming off carbon number 2. So here's your chance to have a practice. How many structural isomers of pentane C5H12 can you draw? Okay, the tip is once you've drawn the isomers, name each compound to ensure that you have not drawn the same structure more than once. Okay, pause the video now and then restart once you've completed the task. Hopefully you will have seen that the pentane has two structural isomers, or there are three isomers with the formula C5H12. The other two isomers are 2-methylbutane. Note that we are counting from the right hand side to give us our number 1, 2 methyl group, and the second compound is 2,2-dimethylpropane. Sorry, there's a spelling mistake there, should be YL. And we've got 1, 2, 3 carbons in our longest carbon chain, and we have got one methyl group here, another methyl group here, both on carbon number 2. Okay, now we're going to look at positional isomers. 1 bromopropane and 2 bromopropane are a nice example of positional isomers. What you can see is that the carbon backbone or carbon chain is unaffected, but the position of the functional group, in this case the bromine, has moved down the chain from carbon number 1 to carbon number 2. So, can you look at C4H9Br and try and identify as many positional isomers as possible? Pause the video and have a go. Okay, now I'm hoping that you will have at least got this far and identified 1 bromobutane and 2 bromobutane as two of the positional isomers. Okay, now it depends on how eager you have been. You may have drawn more isomers, which could be valid structures. This is because each positional isomer has a chain isomer too. So for example, when you take 1 bromobutane, you can change the length of the carbon chain by putting some branching on. Similarly for the 2 bromobutane. If you haven't done that already, have a go now. So in total, we've got 4 structural isomers of the formula C4H9Br. The 2 positional isomers are 1 bromobutane, 2 bromobutane, and then the chain isomers are 1 bromo, 2 methylpropane, and 2 bromo, 2 methylpropane. How many of those did you get? Okay. So, using these 4 structures as a basis, could you find 4 ways of drawing the corresponding chloroalkanes and also the alcohols with the formula C4H10O? So in this case, replace your halogen with an OH. Have a go at trying to draw them all. Okay, so hopefully what you have done with the chloro compounds is essentially just replace your bromine atom for the chlorine atom. So at the top left we have 1 chlorobutane followed by 2 chlorobutane, 1 chloro 2-methylpropane and 2 chloro 2-methylpropane. Hopefully you will have got all of the alcohols as well, starting with butan 1-ol, butan 2-ol, counting now from the right hand side. This compound here, which is 2-methylpropan 1-ol, and this compound here, which is 2-methylpropan 2-ol. We can also see positional isomers of alkenes, and this is exemplified here with but1ene and but2ene. Can you write the names and the structures of all the positional isomers of hex 1ene? Hex 1ene has two positional isomers. These are hex 2ene and hex 3ene. Here is one of the trickier aspects of structural isomers. Cycloalkanes, as exemplified here by cyclohexane, and alkenes have the same molecular formula. So, for example, cyclohexane has the molecular formula C6H12, and hex 1ene here also has 6 carbons and 12 hydrogens. So sometimes the examiner will ask you a question about draw the structure of a cyclic structural isomer of hexene, and what he would be looking for would be cyclohexane. So do bear this in mind. Now we come on to functional group isomers. Again, recalling our definition that they are structural isomers of compounds with the same molecular formula but a different structural formula. The most common example that we will encounter is that of ketones and aldehydes. So propanol and propanal both have the molecular formula C3H6O. Also, another class of compound that you may encounter are alcohols and ethers. Ethers are not on the specification, but previous exam questions have included these. So just be aware that this type of compound is called dimethyl ether. The C-O-C linkage is the ether linkage, or the ether bond. And so these two compounds are classed as functional group isomers. And that brings a conclusion to this video. So hopefully you should be able to go back now, look at the learning outcomes and tick off every single one of them. Thank you for listening.